On my path to describing object-oriented programming, I need to lay some more groundwork. There is the idea of a complex data type, which is generally referred to as a structure. And this is the way it came about. Suppose I'm going to be dealing with your data for your checking account. Now that checking account has several pieces of data associated with it. It's going to have your name, it's going to have the account number, it's going to have the balance, may have a number of other things associated with it, but let's just consider those for the moment. Your name, your balance, and your account number. Now, if you were going to write a program that manipulated those, we'd probably have a variable or a storage location. The reason we call it a variable is because what's in that memory location with that name can change, and often does change during the execution of a program. The whole idea is for the balance to change if we're performing operations. So we'll have customer name, customer account number, and customer balance. Well, those three things really represent one human understandable thing called an account, and every account has one. When I write a program, I could come in and I could say, create me, in some language, create me a variable that stores a customer name that has 20 characters, and call it customer name. Create me a variable that stores the customer account number that's an integer, and call it customer account number. And create customer balance that stores the balance and make it be a numeric value of some type that has at least a couple of decimal places. Now those things are all clustered together, so it is possible to create a new data type based upon existing data types that says, I want to create a data type called customer. And when I create the customer, I want to say create a variable of type customer rather than of type integer or whatever. It is going to allocate one chunk of memory, and the first 20 spaces are going to be the first 20 bytes are going to be interpreted as characters for the customer's name. And the next 4 bytes are going to be interpreted as an integer that is going to store the account number. And the next, depending on what language and whatever, 8 bytes or so are going to store some type of numeric value that can have decimal parts. So I can go ahead and say, create a variable named Joe that is of type customer. And what we're really doing is saying create 3 variables within that chunk of memory. We add up all the memory that each of them takes, and we just chop that out all at once, knowing that the first 20 bytes are going to be name, the next 4 bytes are going to be account number, and the next, say, 8 bytes are going to be the balance. So when I create the variable, I'm basically going to be creating 32 bytes, chopping it out, and we're going to have pieces of it that are going to be interpreted each way. And so if we want to say Joe is a new customer, typically we have a notation that will say Joe.name that will refer to the first parts of the variable location, and then Joe.account number and Joe.balance. So we have this concept called Joe, which is the big storage location, and its different parts we reference by putting a period and then the name of that part. So if I had 2 variables, I might have variable named Joe that's a customer. I might have one that's named John that's a customer. And my account number would be Joe.account number, and his would be John.account number, but they would be of simple data types, integers, that must obey the rules of integers. If they're integers, that means we can't put an account number that has an S or a K or a Q or a May 14th in it. The concept of this complex data type, what I'm calling a complex data type, it's almost uniformly called a structure, made programming a lot easier, because now we could group data together that was logically grouped together and make it programmatically grouped together. And we could also define operations that acted upon the structure to deposit or withdraw, but we still had the problem that the variables and the pieces of those variables were still accessible from any place within the program. And if we were going to go ahead and make a change, we had to make sure we had made the change to every place in the program that made reference to a variable of a particular type.